Hello students, in this video we are going to discuss about another type of mixture that is called as colloidal solutions. As we discussed about solutions in the previous video, in which we have discussed that the particles of one component is uniformly distributed in the particles of other component. That is, here in the solution, the solute and the solvent, there is a uniform distribution of particles here. As in the case of colloidal solutions also, the particles of colloid are uniformly spread throughout the solution. Though it appears to be a homogeneous, but it is not. It is actually a heterogeneous. As according to the observation, it appears like a homogeneous because we could also able to see that the particles are uniformly distributed, but actually it is not a homogeneous, it is a heterogeneous. That is, due to relatively smaller size of the particles, it seems to be homogeneous, but actually it is a heterogeneous mixture. As in the case of solution, we represented the particles like one of the component as represented as solute, the other was represented as a solvent. In the case of colloidal solution also, we represent the particles of one component. Instead of by using the word solute, we can make the use of word here dispersed phase, and in the place of solvent, we make the use of word here dispersion medium. That means instead of using the word solute and the solvent, we can make the use of word dispersed phase and the dispersion medium. So better we can remove the word solute and solvent from here. Now in the case of colloidal solution, one component is called as dispersed phase, the other component is called as dispersion medium, like the case of solute and solvent in the solution. Here, like the solvent, it is present in the larger proportion, that is the dispersion medium. As the solvent, we have defined that the component which is present in the larger proportion, that is called as a solvent. Like the solvent, the dispersion medium can also be defined as the component which is present in the large proportion. That means in compared to the other component, which component is the larger one, that is the dispersion medium. And like the solute, dispersed phase present is in the smaller proportion. Okay, so this is what the definition we can make the use of dispersed phase and the dispersion medium. Thus, the components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in the colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as a dispersion medium. So in the simple word, which is present in the larger proportion, that component is called as dispersion medium, and which is present in the smaller proportion, that is the dispersed phase. Now, it is classified on the basis of the physical state of a dispersed phase and the dispersion medium. Let us see what are the different classification of colloids. That is, if the dispersed phase is liquid and the dispersion medium is gas, that means which is in the larger proportion. If the gas is in the larger proportion and liquid in the smaller proportion, then that type of colloids are called as aerosols. Example, fog, cloud, mist. Next, solid is the dispersed phase, gas is the dispersion medium, then it is also called as aerosol. And here the examples are smoke, because in the smoke there is a minute particles of solid carbon particles, dust particles. So that can be make the example here for the case of solid in the gas type of colloidal solution. That is, smoke is an example, automobile exhaust, because the exhaust coming from the automobiles having the gases, and even the dust particles or the any carbon particles will be there. So that can be taken in the example of solid into gas type of colloidal solution. Next we have a gas and liquid. That means gas is present in the smaller proportion and liquid is in the larger proportion. Example form. Shaving cream is an example for that because in that the gas is in the liquid, we can say. That is the example of shaving cream. That is this type of is called as colloid is called as form. Next we have liquid. That means liquid, one component is the liquid, other component is the liquid. This type of combination is called as emulsion. Example is the milk. So milk example is in the liquid colloidal solution. Next we have solid liquid combination. That means solid in the liquid. That is the example is the milk of magnesia or the mud. So here in this case this is called as sol. Next we have gas and solid. The example we have foam, rubber, and this combination is called as foam. Next we have liquid in the solid. It is called as gel. Example jelly, cheese, butter. Next solid combination, that is called as solid sol. Example colored gemstones. So these are the different type of colloidal solution on the basis of the physical state of dispersed phase and the dispersion medium. So the general examples of colloidal solutions are foams, milk, fog, detergents, that is in the water. Then we have cosmetics, paints, blood. Blood is an example of colloidal solution, and these are the and even the gel. So these are the different common examples of colloidal solution that is quite common in our daily life. Now here we can see what are the properties given for colloidal solution in the textbook. That is, first property, a colloidal solution is a heterogeneous mixture. As I already told you, it appears to be homogeneous, but it is actually heterogeneous mixture. The size of the particles of colloid is too small to be individually seen by the naked eyes. Just like true solutions, here's also the size of the particle is very small. That's why we could not able to see by our naked eyes. But under the high ultra microscope, it can be seen. But it is not seen by our naked eyes. Next is colloids are big enough to scatter the beam of light. Even though it is very small particle, but in compared to the true solution, the particles of colloids are little bit bigger. That is why it could able to scatter the light, and that's why the path is visible. So that we already discussed, and this effect will be called as Tindale effect, that we'll be going to discuss in the detail. And here they do not settle down even left undisturbed. That is a colloid is quite stable. So like the true solution, here the colloid is also stable because it does not settles. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal solution, as it will not settle by itself and it will not get filtered by the ordinary filter paper. But there is a special technique that is called as a centrifugation technique. We'll be going to discuss in detail in the further videos related to centrifugation. So by the technique we could able to separate the particles of colloidal solution. So here we need to discuss about the effect that is due to the scattering of light by the particles of colloid. So in order to discuss that, let us take a true solution and a colloidal solution. And when we pass a beam of light through it, now you can see in the picture the light, by using a torch, a strong beam of light is made to pass through the solution. in the true solution and even the colloidal solution, what would able to see that the particles of colloidal solution scatter the beam of light passing through it and make the path visible. As in the picture also you can see, in the colloidal solution, when we pass the strong light, what could able to see? We could able to see the path of the light. That is actually, you can see a path of the light is visible, but that is not visible in the case of a true solution. That means the particles of true solution is very minute. That's why it will not scatter the light. But the particles of colloidal solution are quite enough in bigger size that it could able to scatter the light. That is why the path of the light is visible. And this is actually the called as scattering of light when it is made to pass through the colloidal solution, and thus it makes the path visible. This effect is called as a Tindale effect, and this is given by the name of John Tindale. That is, this effect was first observed by Faraday and later studied in detail by the John Tindale, and therefore this effect was termed as Tindale effect. Now that is can be seen through this picture. That is, in the container it is taken a colloidal solution, and in the dark it was made to pass a strong light, that is torch can be used for this one. At the time we could able to view the path of the light. The similar one we have seen in the case of forest. That is, the Tindale effect can also be observed when the sunlight passes through a dense forest. This maybe you have experienced in your life, or even you have seen this one in the pictures. So this is actually nothing but the Tindale effect. This is because in the dense forest, mist contains tiny droplets of water which act as a particles of colloid dispersed in the air. So as we have already discussed that mist is also an example of colloidal solution. So in the dense forest, if the sunlight is passed through the air which having the mist, that means when it is passed through the mist, it scatters, that particles scatters the light, and because of this we could able to see this type of image. So that is what actually called as the Tindale effect. The similar effect can be seen when we have seen the fine beam of light when it is enters a dark room through a small hole or a window. So the Tindale effect can also be observed, and this maybe you have observed when a light is made to enter into a room through a small hole or a window. So you have seen such type of the path. Now you can see in this image the path of the light is visible. So the Tindale effect can also be observed when a fine beam of light enters a room through a small hole or a window, because it happens due to the scattering of light by the particles of dust and smoke in the air. Now you will be thinking that where is the colloidal solution? The air which having the dust particles and even the smoke present in the air will act as a colloidal solution. That dust particles will scatter the light. That is, due to this we are getting the path of the light. We could able to visible the path of the light. This effect is called as a Tindale effect. Now let us write down the notes for this topic, that is colloidal solution. First definition: a colloidal solution is a heterogeneous mixture of two or more substances. Example: mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke, etc. Next, properties. Whatever properties we have learned here, let us write it down the points. First property: colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eyes, solute particles cannot be separated by filtration. Solute particles do not settle down. That means the solution is stable and the particles scatter the beam of light passing through it, and thus the path of the light is visible in the solution. So these are the properties related to the colloidal solution. Now in this video we also discussed about Tindale effect. What is Tindale effect? That is, when a beam of light is passed through the colloidal solution, the colloidal particles scatter the beam of light and the path of the light become visible in the solution. This effect is called as Tindale effect. Tindale effect can be seen when the light enters a room through a small hole due to the scattering of light by the dust and the smoke particles, and even we could able to see the Tindale effect in a dense forest when the scattering of light by the water droplets in the mist. So these are the case of Tindale effect. And also we discussed about the two components was named as dispersed phase and the dispersion medium in the colloidal solution. The solute-like component or the dispersed form of is the dispersed phase, and the component in which the dispersion phase is suspended is known as the dispersion medium. So these are the examples, different examples of colloidal solution. So all of you write it on this in the class notebook. So this is all about this video. Have a nice day.